Hello, this is Daryl Presley, and I'm here to talk to you about compound probability, specifically in the subgroup of two draws, exact probability. All right, now it'll make more sense when we look at the problem. Oh, let's make things go away. Okay, here we go. Our problem today, introduced by Fred Flintstone, is a bag. Don't mark the problem out, Presley. Um, A bag contains 8 red marbles, 3 blue marbles, and 2 green marbles. If 2 marbles are drawn out of the bag, what is the exact probability that both marbles will be blue? Okay, so you got a bag of marbles, mixed colors, you pull out one and then you pull out another, and the question is, what's the probability? Sorry about the bell. What's the probability that you get 2 blues? That's all they're asking. Now, I may not do this on every problem, but for this problem, I'm going to draw a little box to represent my bag. And I'm also going to use some colors if I can. I got 8 red marbles. One. Oh, that's too big. Tell you what I'm going to do is I don't want to use the colors. I'm just going to put I'm going to put some reds in there. So 8 reds. So R for red. 1, 2, 3, 4, 5, 6, 7, 8. 8 reds. I'm going to put 3 blues. So B for blue. 3 blues. Sorry about that. And then 2 greens. So I'll put 2 G's for green. Okay. And so we're going to pull out 2 marbles. Well, when you pull out a marble and you're doing probability, you want desired over total. So I'm just going to write that right here. Desired over total. What do you want to happen? How many things in there are what you want to happen, and how many total things could happen? So now look at that bag. I've got 8 plus 3 plus 2, which is 13 marbles total, right? So the total to start with on the first draw is 13. And then how many of those are blue? Well, there's only 3 blue in that bag. All right, so my first draw, I've got a 3 out of 13 chance of getting a blue. There's 3 blues out of 13 marbles. Now, it's asking us to pull out a second marble and that we want them both to be blue. So what that means is, and this is the way I usually do it with my class, is I say, okay, well, I have taken out a blue and I'm not replacing it. And that's what it's asking here. It doesn't say that, but it's saying if you took out 2, all right, that means without replacement. So that blue's gone. So not only do I mark out a B, I also change my total. Now I only have 12. So 12 marbles, okay, and only 2 of those now are blue. So let's highlight a little bit here so you can see what I'm talking about. Here's the 2 blue. See, that's the 2. And the total has changed to 12. Okay, and then I would multiply this across. Now, we could sit here and talk about reducing and so forth, but if you'll type in, you can find plenty of calculators that will reduce fractions for you and multiply fractions for you online. You can also just use a basic calculator like we do in class, scientific. And I think I messed up. I forgot to put times in between. All right, so I got 3/13 times 2/12, and I got 1 over 26 is my reduced answer. All right, so over here for reduced, for answer, I'm going to type 1, and then I'm going to hit I'm going to type it like this, 1/26. And what it'll show up as is as a fraction, because when you hit slash, this delta math will change that to a fraction, and then you type your 26 and hit submit. So that's our answer, 1 out of 20. Not a very good chance of getting 2 blues. 1 out of 26 times. So why? Well, for one thing, there aren't many blues. And for another, when you first take out the blue, that only leaves 2 more blues to go. So that's why it gets really small here as a chance of doing it twice. It can happen, definitely. Is it probable? No. It's like a low chance of rain or something. And I think I have one more problem. That was Fred Flintstone. This is Hong Kong Phooey. You ought to look him up. He's cool. Hong Kong Phooey. All right, well, this is actually the same kind of problem. I just wanted to do it maybe a little bit quicker this time. And again, a simple box helps. So 7 reds and 8 blues. I don't know if I made that box big enough. So I'll draw one more time. I'm giving notes. I might as well do this right, huh? All right, so let me draw a box all the way across. So it's got plenty of room. All right, so 7 reds. Now, you may not like writing this way. You don't have to. You can, a lot of this you can kind of hold in your head. Me, I like drawing it. 8 blues, B for blue. Same thing as last time. I'm just putting letters to represent. I need 2 more. All right, so let's double check. 3, 4, 5, 6, 7 reds, 6, 7, 8, 8 blues, and 3 greens. A lot of marbles this time. And while we're at it, we go ahead and add them up. 7 and 8 is 15 plus 3 is 18, so there's a total of 18 here. Yeah, double checking that. Now this time we want to draw 2 marbles. Exact probability means reduced answer. Both are red. So I want red this time. Well, red to start with is 7 reds out of a total of 18. So 7 reds out of 18. If it helps, let's see if I can do this. Yeah, there'll be a reds, okay? So on the first draw, there are 7 possible reds in that bag out of 18. But if I'm drawing 2 marbles, then one of those has already been red. Now I'm down to 6 marbles. And there's not 18 in there anymore. There's only 17 in there. So I do 7 over 18 times 6 over 17. And why 17? Because one of those marbles is gone. Not only did the number of reds drop, but the total number dropped. Now Presley's a little bit slow. I have to make sure I do this right. And there's nobody to say, hey, Mr. Presley, you did that wrong. So I have to be careful. 7/18, 6/17. 7 over 51 is our answer, and that's what we would type in. 7 over 51. Remember, when you hit that slash button, / button, the delta math will change it to a fraction. Okay? All right, well, I hope you have a good day. I believe that's all I have for you on this video. And please email or let me know anytime you have questions. Also, join my Google Meet. See you later.